Let us imagine a space journey. We have created a perfect ship that can fly anywhere, for as long as we want, and even at a speed close to the speed of light. We leave the solar system behind, fly beyond our galaxy, and continue our path into infinite space. At some point, a natural question arises. Does there exist an end, a boundary, a border beyond which our universe ends? And can we, at least in principle, get there? This question sounds natural because we are used to things that have boundaries. Cities end with roads, countries have borders, and even the ocean, though vast, is not boundless. But when we try to apply this logic to space, we encounter a strange discovery. The universe has no edge in the usual sense. Moreover, we will never be able to escape beyond its limits, even if we wanted to. Hence, a logical question arises. If we can travel this path to the end, are we ever capable of leaving the universe itself? Is there such a boundary beyond which space ends and something else begins? So let's figure this out together. Everything should have a beginning and an end. However, modern science tells us this. The universe has no edge in the sense in which we are used to imagining boundaries, and even those regions of space that, it would seem, could be reached, are in fact separated from us by insurmountable horizons. To understand why escape is impossible, we need to clearly define what we even call boundaries. The first and most obvious border is the observable universe. We live in a universe that is 13.8 billion years old. This means that the light from the most distant objects has had exactly that much time to reach us. If we look only at this number, we see that it is at most 13.8 billion light-years away. But because space is constantly expanding, this distance is much greater. In fact, today, the most distant objects we can observe are located about 46 billion light-years from us. This sphere is our observable universe. Beyond it, objects exist, but we do not see them because their light has not yet had time to reach us. This boundary is called the particle horizon. It is not a material wall. It is simply an information limit. All that is needed is time for the light bubble to inflate and the horizon to expand. But there are other borders as well, in particular the Hubble sphere. In the 1920s, Edwin Hubble established that galaxies are receding from us, and the speed of their recession increases with distance. This became the first evidence that the universe is expanding. The recession speed is determined by Hubble's law. Speed equals the Hubble constant multiplied by distance. If the distance is considerable, then the recession speed can exceed the speed of light. And this does not contradict physics, because galaxies are not moving through space faster than light. The space between us and them is expanding. Therefore, the Hubble horizon is the distance at which the recession speed equals the speed of light. Today, it is about 14 billion light-years. Everything that lies beyond this boundary is receding from us at superluminal speed. Theoretically, we will never be able to catch up with these galaxies, even if we move at a speed close to that of light. Another cosmological horizon is the event horizon. This is the absolute limit of attainability. It defines which corners of the universe can ever send us light, and which will never do so again. Due to accelerated expansion caused by dark energy, the cosmological horizon limits our ability to communicate with distant objects. We can see their past, when they were closer, but everything they emit today or tomorrow will remain forever unattainable for us. This means that any galaxy that is now located farther than 16 billion light-years will never be able to send a signal that will reach us, even if we wait forever. That is, we are already physically cut off from these regions due to the accelerated expansion of space. In other words, any point beyond the event horizon will remain physically unattainable forever, unlike the particle horizon, which can expand over time, allowing us to see new corners of our universe. But does the edge of the universe exist at all? We often imagine it as a giant sphere in a void, and it is logical to assume that beyond this sphere, there is something else. But modern physics refutes such an idea. The universe does not expand into something. It expands in itself. Space has no external container. We cannot ask what is beyond space because the concept of beyond belongs to space itself. You can imagine an analogy with the surface of the Earth. It is finite but boundless. You can travel in any direction, but you will never encounter a wall. Space can be the same, finite yet without edges, or it may be infinite. Then the question of a boundary loses all meaning. Thus, the universe has no edge. There is no place where it ends, and there is certainly no outside world to which one could escape. When we ask whether it is possible to escape beyond the boundaries of the universe, we are essentially trying to think in categories that do not apply to space. We imagine the universe as a room from which one can go outside. But in reality, the universe is space and time themselves. We cannot leave it because we are part of it. Even if we learned to overcome horizons and move faster than light, we would still remain inside space-time. Any point we can reach is already part of the universe. Thus, the question, how to escape beyond the universe, turns out to be incorrect. The only boundaries we encounter are the horizons of our observation and reachability. But this does not mean that we are doomed to limitation. On the contrary, it means that actual infinity is always close by. We cannot leave the universe, but we can endlessly discover new parts of it, expand our horizon of knowledge, and approach those limits that once seemed unattainable. Well, that's all from me. Subscribe to our channel and leave a like if you enjoyed our video. Have a great weekend.